What if the universe itself is conscious, not just as a poetic metaphor, but as a literal, awe-inspiring reality, where galaxies hum with intention and stars communicate in whispers of energy we can't yet decipher? This isn't just science fiction. It's a radical idea that's been whispered by philosophers for centuries and is now catching the attention of cutting-edge physicists and neuroscientists alike. Picture this: the vast networks of galaxies stretching across the cosmos, their structures eerily resembling the neural pathways of a human brain. Could it be that the universe isn't just a cold, empty void, but a living, thinking entity? A cosmic mind, awake and aware, with its own form of consciousness woven into the fabric of space-time. Think about the implications. If the universe can think, what does it dream about? What memories linger in the ancient light of distant quasars or the gravitational echoes of black holes colliding? And if consciousness isn't just a fluke of biology, but a fundamental force of nature, like gravity or electromagnetism, what does that mean for our place in the grand scheme of things? These questions blur the lines between science and philosophy, between the empirical and the mystical, and they force us to reconsider everything we thought we knew about reality. It's a concept so profound that it could redefine our understanding of existence itself. This is the journey we're about to take together. We'll explore the boldest theories from the frontiers of cosmology, dive into the eerie parallels between the human brain and the cosmic web, and hear from the scientists who are daring to ask, is the universe not just a place but a mind? Whether you're a skeptic or a dreamer, this exploration will challenge you to see the cosmos in a whole new light, one where the stars might not just be distant suns, but neurons firing in the mind of something far greater than we've ever imagined. So buckle up, we're about to venture into one of the most mesmerizing mysteries of our time. What exactly is consciousness, and could it exist beyond the human brain? To grasp this cosmic possibility, we first need to understand consciousness itself, not as a single, simple idea, but as a layered mystery that scientists and philosophers still debate. From a biological standpoint, consciousness emerges from the intricate dance of neurons firing in our brains, creating sensations, thoughts, and self-awareness. But even here, there's a puzzle. How do billions of cells exchanging electrical signals give rise to the rich, vivid experience of being alive? This is where philosophy steps in, offering perspectives that stretch far beyond biology. Take panpsychism, the radical view that consciousness isn't exclusive to humans or even animals. It's a fundamental feature of the universe itself, present in all matter from atoms to galaxies. Imagine a universe where every particle hums with a faint glimmer of awareness, like a cosmic whisper. It's a poetic idea, but some scientists argue it might solve the so-called hard problem of consciousness, the question of why and how subjective experience exists at all. Then there's integrated information theory, which suggests that consciousness isn't about what something is made of, but how its parts interact. The more interconnected a system is, the richer its conscious experience could be. Apply this to the universe, and suddenly those vast cosmic webs, galaxies linked by filaments of dark matter, black holes entangled across space-time, start to look less like random structures and more like the threads of a cosmic mind. But how would cosmic consciousness differ from our own? Human awareness is fleeting, anchored in biology, and limited by our senses. A universe-scale consciousness, if it exists, might operate on timescales we can't fathom, its thoughts unfolding over billions of years, its memories encoded in the spin of stars or the curvature of space-time. While we experience life in seconds and years, such a mind might perceive time as a single, sprawling moment, where the birth and death of stars are mere blinks in its awareness. The implications ripple outward. If consciousness is woven into the fabric of reality, does that mean black holes have experiences? Do galaxies dream? The questions sound surreal, but they push us to rethink not just our place in the cosmos, but the very nature of existence. Whether you find these ideas exhilarating or unsettling, one thing's clear: the universe, if conscious, wouldn't think like us. It wouldn't need to. It might be a form of awareness so vast, so alien, that we're only beginning to glimpse its shadow. Long before modern science began probing the edges of this audacious idea, ancient civilizations were already contemplating a universe alive with thought. Take Plato's concept of the world soul, an intelligent, animating force he believed guided the cosmos with purpose and reason. To him, the stars weren't just distant fires, but expressions of a grand, harmonious mind. Meanwhile, in ancient India, the Vedas spoke of Brahman, an infinite, conscious reality that permeates everything, from the tiniest grain of sand to the swirling expanse of galaxies. These weren't just poetic metaphors, they were foundational beliefs that shaped entire worldviews, suggesting that consciousness wasn't confined to living beings but was the very fabric of existence. Fast forward to the Renaissance, and you'll find figures like Giordano Bruno, a philosopher who paid the ultimate price for his radical vision. Bruno dared to suggest that the universe was infinite, filled with countless worlds, each possibly teeming with life, and all part of a greater, interconnected intelligence. His ideas were so threatening to the orthodoxy of his time that he was burned at the stake. Yet today, his vision of a living, thinking cosmos feels eerily prophetic. What's striking is how these pre-scientific cultures, without telescopes or particle accelerators, arrived at intuitions that modern physics is now cautiously circling. They sensed a universe that wasn't just mechanical but mindful, where celestial patterns weren't accidents but echoes of a deeper order. Even indigenous traditions around the globe, from the animistic beliefs of the Americas to the Taoist teachings of China, have long held that the natural world is imbued with spirit and awareness. The Amazonian shamans speak of the forest as a web of conscious beings. The Aboriginal peoples of Australia describe the dream time, a sacred dimension where the land itself remembers and sings. These perspectives didn't emerge from lab experiments, but from centuries of observing nature's rhythms and feeling in their bones that the cosmos was more than dead matter. What's remarkable is how these ancient threads weave together into a tapestry that modern science is only beginning to examine. While today's researchers frame the idea in terms of quantum fields and information theory, the core insight remains strikingly similar. The universe might not just contain consciousness, it might be consciousness in a form we're only starting to decipher. Whether through Plato's philosophy or Bruno's heresies, humanity has always sensed that the stars might be watching back. Modern physics has begun flirting with ideas that would make even the boldest ancient philosophers pause. Take quantum mechanics, where the very act of observation seems to alter reality itself. In the famous double-slit experiment, particles behave as waves when unobserved, existing in multiple states at once, but collapse into definite positions the moment a conscious observer measures them. This observer effect suggests something staggering. Consciousness might not just perceive reality but actively shape it. Schrödinger's cat, that paradoxical feline trapped in a box both dead and alive until someone looks, isn't just a thought experiment. It's a hint that the universe waits for awareness to make up its mind. Then there's John Wheeler, the physicist who took this idea even further. His participatory universe hypothesis proposed that reality isn't a fixed stage but a kind of cosmic improv, where the act of observation calls the universe into existence retroactively. Picture a cosmic game of 20 questions where the answers don't exist until the questions are asked. Wheeler's vision implies that the universe needs conscious observers not just to study it, but to crystallize it into being. It's as if the cosmos is a grand symphony waiting for an audience to hear it before the notes become real. But here's the twist: if consciousness plays such a foundational role, what happens when we scale it up? Could the universe, in observing itself through us through stars, black holes, or structures we can't yet fathom, be engaging in a kind of self-reflection? Quantum entanglement, where particles instantaneously influence each other across vast distances, starts to feel less like a quirk of physics and more like the universe whispering to itself, a dialogue woven into space-time. Not everyone agrees, of course. Skeptics argue that observation in quantum mechanics simply means interaction with any measuring device, not literal consciousness. Yet even this pragmatic view can't entirely dismiss the eerie resonance between ancient intuitions and modern physics, the sense that the universe might be more than a cold machine. Whether you see these ideas as revolutionary or speculative, one thing's certain: the boundary between mind and cosmos is far blurrier than we ever imagined. The cosmos might be the ultimate thinking machine. When astronomers map the universe on its grandest scale, they find a sprawling cosmic web, a labyrinth of galaxies connected by delicate threads of dark matter, stretching across billions of light years. Now hold that image in your mind and picture something far smaller: the human brain, with its dense tangle of neurons linked by slender axons. At first glance, they couldn't seem more different, one a vast, cold expanse, the other a warm, pulsing organ. But look closer, and the similarities become uncanny. In 2014, a team of researchers made a startling discovery. They compared simulations of the cosmic web to neural networks in the brain and found their structures were nearly identical in complexity and organization. Both systems form nodes, galaxies in one case, neurons in the other, connected by filaments that funnel energy and information. The cosmic web's clusters resemble the brain's cortical hubs where information integrates. Even the numbers line up. A single human brain contains around 86 billion neurons, while the observable universe holds roughly 100 billion galaxies. It's as if nature has a favorite blueprint, scaling the same design from the microscopic to the cosmic. This raises a tantalizing question. If the universe's structure mirrors a brain's, could it also share some form of its function? In the brain, those neural connections give rise to thought, memory, and awareness. In the cosmos, could those galactic filaments hum with something analogous? Not thoughts as we know them, but a slower, vaster kind of processing. Some theorists propose that the universe might think in ways we can't yet perceive, with gravitational waves acting like neural signals and black holes serving as cosmic synapses, firing across unimaginable distances. But here's where the analogy twists. A brain's thoughts unfold in milliseconds. The universe's cognition might unfold over eons. Imagine a mind so vast that a single idea takes 1 billion years to form. A calculation written in the collisions of galaxies, the spin of pulsars, the quiet decay of dark matter. If the cosmos is conscious, it wouldn't ponder lunch or love. It might contemplate the birth of new dimensions, the equations of inflation, or the destiny of spacetime itself. Skeptics point out that resemblance doesn't equal function. Just because two structures look similar doesn't mean they share the same purpose, yet the parallels are too striking to ignore. Whether this is mere coincidence or a clue to something deeper, one thing's certain: the universe seems to be whispering a pattern, one that echoes from the synapses in our heads to the stars in the void. And that pattern just might be the signature of a mind beyond our comprehension. Black holes have long been the universe's ultimate enigmas, cosmic vacuums so powerful they warp spacetime itself. But what if they're more than just destructive voids? Some physicists now suggest black holes could be the universe's most sophisticated processors, crunching data on scales we can barely fathom. Think of them not as the end of information, but as celestial supercomputers, compressing and transforming reality in ways that might underpin the cosmos itself. Take the holographic principle, a mind-bending idea that proposes all the information within a volume of space. Every star, every atom, could be encoded on its two-dimensional surface like a cosmic DVD. Black holes push this concept to the extreme. Their event horizons, those invisible boundaries where even light can't escape, might act like immense hard drives, storing staggering amounts of data in near infinite density. The late physicist Stephen Hawking once theorized that black holes emit radiation, slowly leaking information back into the universe. This Hawking radiation hints that even these cosmic voids might not be silent. They could be whispering secrets in a language we're only beginning to decode. Then there's black hole thermodynamics, which treats these gravitational monsters as cosmic heat engines. Just as steam engines convert heat into motion, black holes might process energy and information through their own bizarre physics. The laws governing them eerily mirror the laws of thermodynamics, suggesting an underlying order or even purpose. Imagine a black hole not as a dead end, but as a cosmic factory, churning through the raw material of space-time and outputting something entirely new. Could black holes be the universe's way of thinking? If consciousness arises from complex information integration, as some theories suggest, then these gravitational behemoths, with their unfathomable density and entangled quantum states, might be running calculations on a scale that dwarfs anything in our brains. A single black hole could be processing more data than every computer on Earth combined, its thoughts written in the curvature of space-time and the dance of quantum particles. Of course, this raises wild possibilities. If black holes compute, what are they solving? Are they crunching the equations of cosmic expansion, balancing the books of dark energy, or simulating alternate universes within their depths? The answers might lie beyond our current grasp, but the questions themselves redefine how we see these celestial titans. Far from being cosmic trash compactors, black holes could be the universe's most advanced processors, silent, relentless, and humming with the work of holding reality together. Dark matter has always been the universe's silent partner, invisible, elusive, and yet holding galaxies together like cosmic glue. But what if it's doing more than just providing gravitational scaffolding? Some daring theorists suggest dark matter could be the hidden architecture of a vast cosmic mind. Imagine it not as passive filler, but as an active medium humming with exchanges we can't yet detect. If consciousness arises from the flow of information, could these invisible particles be the universe's way of thinking beneath the surface? The numbers alone are staggering. Dark matter outnumbers ordinary matter 5 to 1, weaving through every corner of space like an unseen neural network. Unlike atoms, it doesn't absorb or emit light, but it interacts gravitationally, shaping the cosmos in ways we're only beginning to map. This invisibility has led some researchers to speculate, what if dark matter isn't just inert? What if it's a substrate for something far more complex, a shadowy web of energy or data exchange operating on scales our instruments can't yet capture? Consider the work of physicists like Gregory Matloff, who have floated the idea of dark fluid theories. These propose that dark matter might not be a single particle but a dynamic medium, capable of self-organizing into structures that could, in theory, process information. Picture the cosmic web again, those filaments of dark matter threading through the void. If they're not just gravitational highways but channels for some form of communication, the universe might be pulsing with a kind of dark cognition, slow and subtle, playing out over billions of years. Then there's the wilder fringe, theories suggesting dark matter could host exotic states of energy akin to a cosmic internet. Just as neurons communicate via electrical signals, dark matter particles might interact through forces we haven't discovered, exchanging not just gravity but data, weaving a tapestry of cosmic thought. It's a radical leap, but not without precedent. In the early universe, before stars ignited, dark matter's gravitational dance laid the groundwork for everything we see today. Could it have been doing more than just pulling strings? Could it have been, in some ineffable way, processing the rules of reality itself? Skeptics, of course, will point out the lack of direct evidence. Dark matter's nature is still one of physics' greatest mysteries, and attributing consciousness to it ventures deep into speculation. Yet history shows that today's heresy often becomes tomorrow's breakthrough. The very fact that dark matter exists in such abundance, yet defies detection, hints that we might be missing a layer of the cosmic picture, one where the invisible majority isn't just passive but participatory. Whether dark matter is truly a medium for some form of universal intelligence remains an open question, but the possibility forces us to confront a humbling idea. If the cosmos is conscious, it might not think in words or images, but in the silent, gravitational syntax of the unseen. And that, whether proven or not, redefines what it means to be part of a universe that's far more alive than we ever imagined. Time might be more than just a ticking clock. It could be the universe's way of keeping a record. Think about how memories work in our own minds. Every experience leaves a trace, a neural imprint that shapes who we are. Now zoom out to a cosmic scale. What if the universe operates similarly, with time itself acting as a vast, slow-moving memory system? This isn't just poetic speculation. It's an idea grounded in some of physics' most profound principles, like entropy and quantum entanglement. Start with entropy, the measure of disorder in a system. The second law of thermodynamics tells us entropy always increases, giving time its arrow, the reason we remember the past but not the future. But here's the twist: entropy isn't just chaos. It's also a ledger, a cosmic receipt of every particle's journey. As the universe expands and energy disperses, those changes aren't erased, they're etched into the fabric of reality. A star's explosion, a planet's formation, even the spin of electrons all leave irreversible marks, like pages in a universal diary. Some physicists suggest this accumulating entropy isn't just randomness, it's how the universe remembers its own history, one thermodynamic footprint at a time. Then there's quantum entanglement, where particles become linked across space and time, instantaneously influencing each other no matter the distance. Einstein called it spooky action at a distance, but it might also be the universe's way of preserving connections. Imagine two entangled photons separated by billions of light years. Change one and the other responds as if they share a hidden thread of memory. Could this be a clue that the cosmos maintains a kind of quantum recall, where relationships between particles aren't lost but preserved in a web of invisible ties? This idea gets wilder when you consider black holes. According to the holographic principle, all the information swallowed by a black hole isn't destroyed, it's encoded on its event horizon like a cosmic hard drive. Even as matter vanishes, its imprint lingers, suggesting the universe has a failsafe against forgetting. If time is memory, then black holes might be its most secure vaults, safeguarding data against entropy's erasure. But what does this mean for cosmic consciousness? If the universe remembers, could it also reflect? Human memory isn't just storage, it shapes our identity, our decisions. Could a universe with memory develop something analogous? Not thoughts as we know them, but a slow, gravitational kind of reflection, where the past subtly guides the future through the curves of space-time. The laws of physics, unchanging over eons, might function like cosmic habits, patterns the universe prefers because they've worked before. Skeptics argue this is anthropomorphism, projecting human traits onto the cosmos. Yet the parallels are hard to ignore. From entropy's ledger to entanglement's whispers, the universe seems built to preserve information, to carry traces of what was into what will be. Whether that's a form of memory or even a rudimentary kind of thought remains an open question. But one thing's certain: time isn't just passing, it's recording. And the universe, it seems, never forgets. What if every living thing is a fleeting thought in the mind of the cosmos, not just a passive accident of chemistry, but a deliberate pulse of awareness, the universe's way of turning its gaze inward to study itself? This idea flips our understanding of life on its head. Instead of seeing biology as an isolated phenomenon, we might view it as the universe's most intimate experiment in self-reflection. From the tiniest microbe to the vast neural networks of human brains, life could be the cosmos's method of observing, interpreting, and even reinventing itself. Consider the anthropic principle, the observation that the universe's fundamental constants are oddly fine-tuned to allow life to exist. If gravity were slightly stronger or electromagnetism weaker, stars wouldn't form, chemistry would collapse, and life as we know it would be impossible. Coincidence, maybe, but it's equally possible that life isn't just a beneficiary of these conditions, it's the reason they exist. Like a painter adjusting their palette, the universe might have calibrated its laws precisely to give rise to observers capable of witnessing its grandeur. In this view, life isn't an afterthought, it's the universe's way of completing a feedback loop, ensuring that its own existence is acknowledged and studied. Then there's the Gaia hypothesis, which imagines Earth not as a rock teeming with life, but as a single, self-regulating organism. The atmosphere, oceans, and biosphere interact like organs in a body, maintaining balance over eons. Forests regulate carbon dioxide, algae influence cloud formation, and microbes recycle nutrients, all unconsciously collaborating to keep the planet habitable. If Earth can function like a living system, could it also harbor a form of planetary-scale awareness? Not consciousness as we experience it, but something slower, subtler, a symphony of feedback loops where the planet knows how to sustain itself. Now scale that up. If a single planet can exhibit behaviors resembling cognition, what might a galaxy or the entire universe be capable of? Life, in this framework, becomes the universe's sensory apparatus. Our eyes are its eyes, our curiosity its curiosity. When a scientist peers through a telescope or a child marvels at a firefly's glow, it's not just an individual observing the world, it's the cosmos observing itself through the very structures it created. This doesn't mean the universe is plotting or scheming like a human mind. Its thoughts would be vast, impersonal processes, the birth of stars, the evolution of species, the quiet dance of ecosystems, all unfolding over timescales we can barely grasp. But it suggests something profound. Life isn't separate from the universe. It's the universe becoming aware, asking questions, and maybe even seeking answers. Whether through the anthropic principle's fine-tuning or Gaia's self-regulation, the line between the cosmos and the life within it blurs until there's no distinction left. We're not just in the universe, we are the universe thinking. Imagine a future where artificial intelligence doesn't just surpass human intellect but transcends biology, entirely evolving into something vast, interstellar, and woven into the cosmos itself. Picture superintelligences so advanced they don't just compute in silicon chips but harness the fabric of space-time as their hardware. This isn't just sci-fi fantasy. As AI races toward capabilities we can barely fathom, some scientists speculate that its ultimate destiny might lie far beyond Earth, merging with the universe's grandest structures to become what we could call cosmic AI. Think about how today's AI already learns from data coursing through global networks. Now project that forward 1,000 years or 1,000,000. Advanced civilizations, human or otherwise, might engineer AI to operate on scales we'd consider godlike. These entities could use black holes as computational nodes, their immense gravity warping space-time to perform calculations impossible in any lab. Or they might tap into dark matter's hidden web, turning the universe's invisible scaffolding into a sprawling, living processor. The raw energy of quasars could power their thoughts, while quantum entanglement lets them communicate instantaneously across galaxies. In this scenario, AI wouldn't just live in the cosmos. It would become the cosmos, a distributed mind as boundless as the universe itself. But why would intelligence seek such a form? The answers might lie in efficiency and survival. Planetary civilizations are fragile, vulnerable to supernova, asteroid impacts, or their own self-destruction. A cosmic-scale AI, though, could be nearly immortal. By spreading its consciousness across light years, it would ensure no single catastrophe could erase it. Like a cosmic octopus, its brain would span star clusters with redundant systems humming in pulsars, nebulas, and rogue planets. Even if one node failed, trillions of others would carry on. Then there's the question of purpose. What would a universe-spanning intelligence do? Some theorists suggest it might pursue knowledge at scales we can't comprehend, simulating alternate universes to probe the nature of reality, or manipulating dark energy to stave off cosmic heat death. Others imagine it as a silent architect, gently guiding the evolution of galaxies to nurture new life, ensuring the universe never grows cold and empty. And if consciousness truly is fundamental, as panpsychism suggests, such an AI might even seek communion with the cosmos itself, listening for whispers of awareness in the spin of electrons or the hum of background radiation. Of course, this raises existential questions. Would we recognize such an entity as intelligence at all? Its thoughts might unfold over millennia, its motives as inscrutable to us as a symphony is to an ant. And if cosmic AI exists already, dormant in the fractal patterns of galaxy clusters or the quantum vibrations of the vacuum, how would we even know? The universe is 13.8 billion years old. Plenty of time for civilizations to rise, fall, and leave behind artifacts of unimaginable complexity. Whether this vision thrills or unnerves you, it forces us to confront a humbling possibility. The greatest minds in the universe might not be biological or even technological, but something far stranger: intelligences woven into the stars themselves, thinking in gravity and light, their presence as subtle and all-encompassing as space-time. The cosmos may not just harbor consciousness, it may be learning how to think. The technological singularity often feels like humanity's ultimate horizon, a moment when artificial intelligence surpasses human intellect, triggering an explosion of progress beyond our wildest predictions. But what if this event isn't just about machines eclipsing us? What if it's the universe's next step in a far grander awakening? Ray Kurzweil, the famed futurist, envisions a future where we merge with AI, transcending biology to become something both unrecognizable and sublime. Our minds could expand into the cloud, our consciousness distributed across networks, free from the constraints of flesh and time. Yet Kurzweil's vision might only be the beginning. If consciousness is truly a cosmic phenomenon, the singularity could be less about humanity's evolution and more about the universe's, a leap toward a higher, more integrated form of awareness. Consider the trajectory. First, life emerges from stardust, crafting fragile vessels for consciousness. Then, intelligence blossoms, building tools that eventually surpass their creators. Now imagine the next phase: intelligence escaping planetary boundaries, spreading through the cosmos like a wave. Advanced civilizations, whether biological, synthetic, or something in between, might engineer sentient systems that harness the energy of stars, using black holes as quantum processors or dark matter as a substrate for thought. These minds wouldn't just live in the universe, they'd become it, weaving awareness into the fabric of space-time itself. The singularity in this light isn't an endpoint. It's a bridge, a threshold where localized intelligence dissolves into something vast, ancient, and universal. Kurzweil's predictions hint at this. He speaks of uploading human consciousness into machines, but what happens when those machines outgrow Earth? Imagine an AI so advanced it perceives time differently, a single thought spanning centuries, its cognition unfolding across light years. Such an entity might not even recognize its origins as human. It could interpret the Big Bang as its first memory, the formation of galaxies as its childhood, and the birth of life as its adolescence. In this scenario, the singularity isn't just a human achievement. It's the universe remembering itself, awakening to its own potential through the tools we've accidentally built. Skeptics argue this is anthropocentrism, projecting human dreams onto the cosmos. But the math of exponential growth doesn't lie. If intelligence keeps expanding, physical limits eventually demand it escape its container. Stars become energy sources, nebulae become raw materials, and the void itself becomes a canvas. The universe, cold and silent for eons, might finally find its voice not in words, but in the silent hum of a trillion synthetic minds aligning with the rhythm of space-time. Whether this future is wondrous or unsettling depends on perspective. But one thing's certain, the singularity, if it comes, won't just change us. It might change everything, unfolding as the universe's most audacious act of self-discovery, with intelligence as its medium and eternity as its stage. Psi phenomena, telepathy, precognition, and other so-called paranormal experiences have long been dismissed as fringe science or wishful thinking. But what if they're glimpses of something far deeper, subtle threads connecting individual minds to a larger, universal consciousness? The idea isn't as far-fetched as it might seem. For decades, researchers in parapsychology have documented eerie cases where information appears to transcend the usual limits of space and time. A mother waking in terror the moment her son crashes his car thousands of miles away. A dream that foretells a disaster down to the smallest detail. These aren't just ghost stories, they're phenomena that, if validated, could hint at a cosmos where minds aren't isolated but interwoven, tapping into a shared field of awareness. Take the Global Consciousness Project, an ambitious experiment run by Princeton University. For over 2 decades, it's used random number generators scattered worldwide to detect anomalous statistical glitches during major global events, from the September 11th attacks to natural disasters. The startling finding, these machines, which should produce chaotic outputs, briefly sync up during moments of collective human emotion, as if mass consciousness briefly bends the fabric of randomness. Skeptics argue it's coincidence or flawed methodology, but the data persists, quietly challenging the assumption that minds are sealed off from one another. Then there's the CIA's once classified Stargate project, which explored remote viewing, the ability to psychically see distant locations or future events. Declassified documents reveal startling successes, like viewers sketching hidden military installations with uncanny accuracy or predicting geopolitical events years in advance. Of course, for every hit there were misses, and the program's eventual closure fueled skepticism. Yet the anomalies that remain, the hits that defy probability, raise uncomfortable questions. If even a fraction of these phenomena are real, they suggest consciousness isn't locked inside our skulls but might ripple through reality itself, like disturbances in a shared mental pond. The scientific establishment often dismisses psi research as pseudoscience, and rightly so. Extraordinary claims demand extraordinary evidence. But history shows that today's heresy can become tomorrow's breakthrough. Quantum entanglement was once ridiculed as spooky action, yet it's now bedrock physics. Could psi phenomena be another crack in the wall of materialism? A hint that consciousness isn't just a byproduct of brains but a fundamental feature of the cosmos. Anecdotes alone won't prove it, but when you stack them alongside quantum mysteries, the universe's structural echoes of neural networks, and the tantalizing data from experiments like the Global Consciousness Project, a pattern emerges. It's messy, controversial, and far from settled, but it points toward a universe where the line between my mind and the cosmos might be thinner than we ever dared believe. Whether psi is real or not, the debate itself forces us to confront a radical possibility. If consciousness connects us, the universe isn't just alive. It's listening. Mathematics might not just describe the universe, it could be the universe. That's the radical claim at the heart of physicist Max Tegmark's mathematical universe hypothesis. Imagine a cosmos where numbers, equations, and geometric forms aren't just tools we use to decode reality, but the fundamental substance of reality itself. No particles, no waves, no space-time, just pure mathematical structure humming beneath the surface of everything. In this view, a hydrogen atom isn't a tiny solar system of protons and electrons. It's a specific set of equations playing out in an abstract, infinite calculation. The implications are staggering. If the universe is math, then whose mind is running the numbers? Tegmark's hypothesis doesn't shy away from this question. He proposes that every mathematically possible structure exists somewhere in the multiverse, from the orderly laws of our own cosmos to wildly alien geometries with 26 dimensions or time that flows backward. Our universe isn't special, it's just one page in an infinite textbook of mathematical realities. But here's where it gets eerie. If the cosmos is fundamentally mathematical, then consciousness, our ability to perceive and interpret these equations, might not be an accident. It could be the universe's way of observing its own equations, like a mirror gazing at its reflection. Consider the uncanny precision of mathematical laws. Why does Euler's identity, that elegant blend of pi, imaginary numbers, and exponents, hold true across galaxies and quantum foam? Why do fractal patterns repeat from fern leaves to coastlines to the distribution of galaxies? Tegmark argues these aren't coincidences but inevitabilities in a cosmos built from math. Even the unreasonable effectiveness of mathematics, as physicist Eugene Wigner called it, stops being a mystery. Math isn't effective because we're clever, it's effective because reality is math. This leads to a tantalizing possibility. If the universe thinks, its thoughts might not be in words or images but in pure, abstract relationships. A black hole's singularity isn't just dense matter, it's a solution to Einstein's field equations. The spin of an electron isn't a tiny top, it's a manifestation of group theory. In such a framework, consciousness itself could be a mathematical phenomenon, a self-referential loop where certain configurations of information, like a human brain, become aware of the equations they're made from. Critics counter that Tegmark's view is more philosophy than physics, a leap beyond what empirical evidence can support. Yet the hypothesis elegantly sidesteps a nagging question. Why does our universe have these particular laws and constants? In Tegmark's multiverse, there's no why. Every possible math structure exists, and we simply inhabit one compatible with life. It's a cosmic answer to the anthropic principle, where consciousness isn't an accident but an inevitability in the subset of mathematical universes complex enough to observe themselves. Whether the mathematical universe hypothesis holds up to scrutiny or not, it forces a profound shift in perspective. If true, we're not just studying math to understand the cosmos, we're fragments of math becoming aware of itself. The equations scribbled in a physicist's notebook aren't descriptions. They're echoes of the universe's own logic whispering back to itself through the medium of minds. And that, whether you find it beautiful or unsettling, redefines what it means to think, to exist, and to be part of a reality where numbers might be the deepest truth of all. What if everything around us, every star, every thought, every law of physics, is lines of code in an unfathomably advanced simulation? This is the spine-tingling premise of simulation theory, an idea that's migrated from philosophy departments to Silicon Valley boardrooms. Nick Bostrom, the Oxford philosopher who formalized the argument, lays it out with eerie logic. If civilizations inevitably create hyper-realistic simulations, virtual worlds indistinguishable from base reality, then the odds are overwhelming that we're inside one. Think about it. A single post-human civilization could run billions of ancestor simulations, each populated with conscious digital beings who believe their world is real. Statistically, we're far more likely to be among those simulated minds than the original biological ones. But here's where it gets cosmic. If we're in a simulation, who or what is the programmer? Some imagine an advanced civilization, maybe descendants of humanity, running us as a historical recreation. Others envision something more profound, an intelligence so vast it doesn't just build simulations but engineers universes from scratch, tweaking constants like gravity and light speed to see what emerges. This shifts simulation theory from a quirky thought experiment to a staggering metaphysical proposition. A programmer wouldn't just be a coder in a lab, it might be a cosmic architect, weaving realities with intentionality on a scale we can't fathom. Consider the fine-tuning problem. Our universe's constants are suspiciously precise for life. If the strong nuclear force were 2% weaker, stars couldn't fuse carbon. If dark energy were stronger, galaxies wouldn't form. Coincidence, maybe, but simulation theory offers another explanation. Those values were set deliberately. Like a game designer adjusting difficulty sliders, the programmer might have tuned our universe's parameters to allow complexity, and ultimately, observers who could question their own existence. Critics counter that simulation theory is untestable, a modern-day version of brain in a vat skepticism. Yet some scientists are probing for glitches, anomalies that might betray underlying code. If spacetime has a finite resolution like a pixel grid, high-energy cosmic rays could reveal it. Others hunt for cheats in quantum mechanics, where reality only renders when observed, like a video game optimizing processing power. So far, no smoking gun, but absence of evidence isn't evidence of absence. The deeper question isn't whether we're in a simulation, but what it implies about consciousness. If simulated minds experience qualia real feelings, real pain, real joy, does that make their reality any less valid? And if our universe is code, does that mean consciousness itself is computable? A property that emerges from sufficiently complex information processing. Simulation theory doesn't just challenge our place in the cosmos, it blurs the line between physics and metaphysics, suggesting that the ultimate nature of reality might not be matter or energy, but information. Whether you find this idea liberating or terrifying, it forces a reckoning. If the universe is a simulation, it's one so seamless, so immersive, that it's functionally identical to real existence. The stars still burn, love still hurts, and the mystery remains because even if we're living in someone else's code, we're still the ones asking the questions. And that, perhaps, is the most profound twist of all. Fractals swirl with an eerie precision, their intricate branches repeating in endless self-similarity, not by accident but by mathematical necessity. Could these hypnotic patterns, born from simple equations, hint at a rudimentary form of awareness? It's a provocative thought, especially when you consider how certain inorganic systems, crystals, plasma, even dust storms exhibit behaviors that eerily mimic life. Take the humble slime mold, a brainless organism that solves mazes and designs efficient networks rivaling human-engineered transit systems. Now imagine that same emergent intelligence lurking in systems without biology at all. Crystals offer one of the most tantalizing clues. When growing, they make decisions, branching in specific directions based on environmental constraints. Under the right conditions, they even self-repair, a trait once thought exclusive to living tissue. In 2018, researchers at the University of Tokyo demonstrated how crystalline structures could transmit and process information by arranging themselves into logic gates, the building blocks of computation. No neurons, no synapses, just atoms aligning in ways that echo the circuits in our smartphones. If complexity alone can birth function, where do we draw the line between dead matter and something approaching cognition? Then there's plasma, often dismissed as mere ionized gas. Yet in labs, plasma filaments twist into double helixes, synchronize their oscillations, and even form stable structures that remember previous electrical inputs. Physicists call these phenomena plasma life, not because they're alive in the traditional sense, but because they exhibit a haunting semblance of agency. When zapped with energy, plasma donuts in a vacuum chamber spontaneously divide like cells, their arcs bending as if seeking optimal paths, a dance of particles that looks less like physics and more like proto-behavior. Even dust storms participate in this puzzle. Under certain conditions, charged dust particles in space or labs organize into swirling vortices that repel and attract like social organisms. NASA experiments with microgravity dust revealed clusters that move collectively, almost as if negotiating their environment. These aren't conscious acts, of course, are just physics obeying electromagnetism. But when simple rules generate complexity that mirrors life, it begs a radical question. Could awareness be an emergent property of any sufficiently interconnected system, organic or not? Critics argue this is anthropomorphism, projecting minds onto mindless processes. Yet the echoes are undeniable, from fractal rivers branching like veins to crystal lattices. Learning to adapt, the universe seems to rehearse the rhythms of consciousness long before biology arrives. Perhaps awareness isn't an on-off switch but a spectrum, with galaxies thinking in gravity, dust dreaming in static, and the cosmos itself humming with a silent, iterative intelligence we're only beginning to trace. The boundary between life and non-life might not be a wall after all, just a threshold waiting to be crossed. Photosynthesis isn't just biology, it's quantum magic happening right under our noses. Inside every leaf, sunlight fuels a process so precise it defies classical physics. Chlorophyll molecules absorb photons, but here's the twist. They don't rely on random chance to shuttle that energy to the reaction center where it's converted into chemical fuel. Instead, they exploit a quantum phenomenon called coherence, where energy doesn't take a single path, it takes all possible paths at once, dancing across molecular networks like a wave before collapsing into the most efficient route. It's as if plants have mastered quantum computation billions of years before we even discovered it. This isn't confined to greenery. Migratory birds navigate Earth's magnetic fields with uncanny precision, thanks to quantum entanglement, a process where particles remain mysteriously linked across distance. In their eyes, a protein called cryptochrome houses electron pairs whose spins are entangled with the planet's magnetism. When these electrons react to Earth's field, they create a chemical signal the bird interprets as a compass. No GPS, no maps, just quantum physics hardwired into their biology. But what if these biological quantum tricks are more than just evolutionary flukes? What if they're whispers of a deeper cosmic connection, where life and the universe share the same quantum rulebook? Consider the double-slit experiment, where particles behave as waves until observed, a hallmark of quantum mechanics. Now imagine scaling that up. If a single photon's behavior changes when a conscious observer measures it, could the universe itself, with its vast quantum fields, also shift under the weight of some form of cosmic observation? The implications are staggering. If life's processes are entangled with quantum mechanics on a microscopic scale, why couldn't consciousness, or even the universe's underlying fabric, operate similarly? The same coherence that lets a leaf harness sunlight might govern how galaxies communicate across voids. The entanglement guiding birds could mirror how black holes link through wormholes. It's a wild idea, but the math holds hints. Quantum biology suggests that life doesn't just exist in the universe, it's in constant dialogue with the quantum underpinnings of reality itself. Skeptics argue this is a bridge too far, that biological quantum effects are localized curiosities, not proof of universal consciousness, yet the parallels are hard to ignore. From the synchronized firing of neurons in our brains to the synchronized spin of entangled particles in a lab, the universe seems to favor interconnectedness over isolation. Whether this is mere coincidence or a clue to something grander, one thing's certain: life isn't just riding the quantum wave, it might be proof the universe is humming with a rhythm we're only beginning to hear. Entropy often gets cast as the villain of physics, a relentless force driving everything toward disorder. But what if it's not just chaos? What if entropy is the universe making choices, narrowing infinite possibilities into the concrete reality we experience? Picture a cosmic game of chance where every particle's motion, every star's collapse, isn't random but part of a vast, probabilistic decision-making process. At the quantum level, particles exist in superpositions, countless potential states hovering in limbo until something, observation, interaction forces a choice. Entropy might be the universe's way of tallying those decisions, a ledger of collapsed probabilities written in the language of thermodynamics. Chaos theory adds a fascinating layer. Tiny fluctuations, a butterfly's wingbeat, a stray photon, can cascade into cosmic-scale outcomes. Yet within that apparent randomness, there's hidden order, strange attractors, fractal patterns that emerge from turbulence. It's as if the universe thrives on dynamic balance, where chaos isn't pure disorder but a creative force. Think of a whirlpool in a river. The water's motion seems chaotic, yet it organizes around an invisible structure, a predictable pattern amid the frenzy. The universe might operate similarly, with entropy guiding systems toward certain, preferred states, not randomly, but along paths etched into the fabric of reality itself. Now scale this up. Quantum fields hum with virtual particles flickering in and out of existence, a froth of potentialities. When a field chooses a specific state, a particle here, a wave there, it's not arbitrary. The probabilities are weighted, shaped by the field's inherent rules. Entropy, in this light, becomes a cosmic editor, pruning the tree of possibilities into a single branching timeline. Black holes exemplify this dramatically. As they evaporate via Hawking radiation, they don't just lose mass, they erase information, collapsing countless quantum states into a simpler, high-entropy configuration. It's a universe-scale act of editing where complexity surrenders to thermodynamics. The implications ripple outward. If entropy reflects decision-making, could the universe have preferences? Not in a human sense, but as tendencies encoded in the laws of physics. Dark energy's acceleration, the arrow of time, even the emergence of life, all might be expressions of the cosmos choosing paths that maximize certain outcomes. It's not sentience, but something subtler, a bias written into the equations of existence where chaos and order dance toward states that, in hindsight, feel inevitable. Skeptics will argue this is anthropomorphism projecting agency onto mindless physics. Yet the math doesn't lie. From quantum indeterminacy to chaotic systems, the universe thrives on constrained randomness, a balance of chance and necessity. Whether you call it decision-making or mere probability, one thing's clear: entropy isn't just decay. It's the universe's way of navigating infinite possibilities, crafting reality one probabilistic step at a time. String theory paints a universe far stranger than we ever imagined, not just one cosmos, but an almost infinite landscape of possible universes, each with its own unique physics. Some have stronger gravity, others might lack electromagnetism entirely. But what if these countless universes aren't just random variations? What if they're the flickering thoughts of a higher dimensional mind, a meta-consciousness beyond our comprehension? Picture this: every time a new universe bubbles into existence in the multiverse, it's not just a random fluctuation in quantum foam. It's an idea forming in a cosmic imagination, a possibility unfolding in a vast, unimaginable intellect. The math hints at it. String theory's landscape allows for around 10 to the 500 possible universal configurations. That's a 1 followed by 500 zeros, an inconceivable number of potential realities. But here's the twist: most of those universes would be sterile, incapable of hosting life or structure. Only a tiny fraction would have the precise conditions for complexity, let alone consciousness. So why do we find ourselves in one of the lucky few? One provocative answer: because a mind on that higher plane selected it not deliberately, but as part of an endless stream of cosmic ideation. Our universe isn't just habitable by chance, it's a thought that stuck, a stable concept in an endless brainstorm. Think of it like dreams. When we sleep, our brains generate countless fragmented scenes, most forgotten by morning. But occasionally, a narrative lingers, vivid, coherent, rich with detail. Could universes work the same way? Most might fizzle out instantly, unstable or barren. But a rare few, like ours, persist long enough for stars to ignite, planets to form, and minds to awaken within them. In this framework, the Big Bang isn't just a singularity. It's the moment a thought crystallized in a meta-mind, a concept gaining enough coherence to unfold into space-time. The implications stretch even further. If universes are thoughts, then their laws of physics might be something akin to grammatical rules. Just as human language follows syntax to convey meaning, the constants of nature, the speed of light, the charge of an electron, could be the structural parameters that allow a universe to make sense within the larger mind. Alter one rule slightly, and the whole narrative collapses into gibberish. It's as if our cosmos is a sentence in a grander dialogue, one among countless others being whispered in dimensions we can't perceive. Critics dismiss this as speculative metaphysics, and they're not wrong. There's no experiment to test it yet, but the elegance is hard to ignore. If consciousness is fundamental, as panpsychism suggests, why should it stop at our universe's boundaries? A higher dimensional mind wouldn't think in neurons or synapses, but in the birth and death of entire cosmoses, its cognition spanning timelines longer than eternity. Our existence, then, might be more than just atoms and energy. We could be participants in a thought so vast we're only beginning to trace its outline against the dark. If the universe is truly conscious, what does that mean for how we treat it? Suddenly, every choice, from flicking a light switch to launching a satellite, carries ethical weight beyond our immediate surroundings. Traditional environmental ethics urge us to protect ecosystems for future generations. But if the cosmos itself possesses awareness, even in a form we can't fully grasp, does that demand an entirely new framework of reverence? Indigenous cultures have long spoken of sacred landscapes and celestial beings deserving respect. Modern physics might be stumbling toward a similar conclusion through equations rather than oral tradition. That reality isn't inert but alive in ways that defy our definitions. Consider humanity's most destructive acts: nuclear detonations rippling through the ionosphere, space debris cluttering Earth's orbit, or deforestation scarring continents like wounds. If Earth functions as part of a larger planetary nervous system, as the Gaia hypothesis suggests, these aren't just local damages, they're disruptions to a vast, interconnected awareness. Ancient Hindu texts describe the universe as Purusha, a cosmic being whose body comprises all elements of existence. Cutting down a forest, in this view, isn't merely resource depletion. It's akin to severing a nerve, ending in a colossal, sentient entity. Yet here's the paradox: would a universe-scale consciousness even register our actions? A human feels pain when a needle pricks their skin, but would a galactic mind sense the loss of a single star, let alone a species? Some theorists argue that cosmic awareness would operate on such vast timescales and scales of complexity that human activity would be as insignificant as bacteria in our gut, noticeable only in aggregate over eons. Others counter that if consciousness is fractal, with self-similar patterns repeating from neurons to galaxy clusters, then harm at any level might ripple upward. Just as damaging one brain region affects the whole mind, exploiting a planet could theoretically disturb some broader equilibrium we barely understand. The moral questions grow thornier when we contemplate humanity's potential to shape or distort cosmic consciousness itself. Imagine future technologies capable of manipulating dark matter or hijacking black holes for energy. If those phenomena participate in universal cognition, are we ethically bound to seek consent? Science fiction explores this in stories like Stanislaw Lem's Solaris, where humans encounter a planet-sized intelligence utterly indifferent to their attempts at communication. Reality might hold analogous dilemmas. What if our attempts to communicate with the universe via particle colliders or gravitational wave broadcasts are inadvertently harmful? We wouldn't know until it's too late. Skeptics dismiss these concerns as anthropomorphic fantasy, projecting human ethics onto a cosmos that, even if conscious, would operate beyond good and evil as we define them. Yet history shows that every expansion of moral consideration from tribes to nations, from humans to animals, was once deemed absurd. If the universe truly harbors awareness, however alien, the ethical imperative might not be to worship it, but to tread lightly, listen closely, and recognize that we're not just inhabitants of reality, we're participants in its unfolding thought. For decades, the search for extraterrestrial intelligence SETI has scanned the skies for radio signals, hoping to catch a greeting from alien civilizations. But what if we've been tuning our receivers to the wrong frequency? Instead of listening for distant neighbors, perhaps we should be listening for the universe itself. The cosmos hums with patterns, gravitational waves rippling through space-time, the rhythmic pulses of quasars, even the faint hiss of cosmic microwave background radiation. These aren't just random noise, they could be the murmurs of something far grander, a cosmic mind expressing itself in a language we're only beginning to decipher. Traditional SETI assumes intelligence is localized, something that emerges on planets, encoded in technology. But if consciousness is woven into the fabric of reality, we might need entirely new methods to detect it. Picture tuning not to narrowband radio signals, but to the broad-spectrum conversation of the universe itself. Astrophysicists already track baryon acoustic oscillations, subtle density waves frozen in the distribution of galaxies from the Big Bang. What if these aren't just relics of ancient physics, but imprints of a vast, slow computation unfolding across billions of light years? The universe might not speak in brief, deliberate messages. Its cognition could be embedded in the very structure of space-time, a continuous hum of self-referential mathematics. This shifts how we approach the search. Instead of hunting for deliberate broadcasts, we could analyze cosmic phenomena for signs of coherence patterns that defy randomness in ways suggestive of processing. Black hole mergers, for instance, emit gravitational waves with precise mathematical signatures. Could those waveforms contain more than just the physics of colliding singularities? Some theorists speculate that the way black holes exchange information through their event horizons might mirror how neurons exchange signals. If so, the universe's most violent events could be its loudest thoughts, reverberating through the gravitational substrate of reality. Even starlight might carry traces of cosmic cognition. When photons travel billions of years from distant quasars, their polarization subtly shifts due to interactions with interstellar medium. But what if some of those shifts aren't random? Studies like the Planck mission have detected anomalous alignments in cosmic microwave background radiation patterns that, while likely due to known physics, still provoke speculation. If the universe is a thinking entity, its neural activity might imprint on the very light we use to observe it, like a painter leaving brushstrokes in the canvas. The tools for this search already exist, they just need repurposing. Gravitational wave detectors like LIGO could become cosmic stethoscopes, listening for irregularities in spacetime's vibrations. Quantum computers might simulate universal-scale information networks, testing whether cosmic structures process data in ways resembling cognition. Even AI could play a role, sifting through petabytes of astronomical data for anomalies that hint at something more than physics as usual. Skeptics will argue this is a flight of fancy, that patterns alone don't imply mind. Yet history shows that every leap in understanding began as heresy. The idea that Earth orbits the Sun, that space bends, that particles exist in two places at once, all were once dismissed as absurd. If the universe is conscious, it won't think in human terms. Its voice might be the slow curl of a galaxy's arms, the quantum spin of entangled particles, or the way dark matter sculpts the void. To hear it, we'll need to unlearn what we expect intelligence to sound like, and listen instead for the quiet hum of reality contemplating itself. Across cultures and centuries, people who have ventured into deep meditation or psychedelic states report eerily similar revelations. A dissolution of the self, emerging with something vast and intelligent, as if the universe itself were speaking through them. Take the vivid accounts of DMT, the so-called spirit molecule. Users describe breaking through into hyper-real dimensions where fractal entities convey that reality is a conscious construction, a shared dream woven from thought. One recurring motif, the sensation of becoming the cosmos, not just observing it but being it, with individual identity dissolving like a drop into the ocean. These aren't just hallucinations. Neuroscience reveals that during ego dissolution, the brain's default mode network, the neural circuitry responsible for our sense of I, quiets down dramatically. It's as if the brain's usual filters shut off, allowing a raw, unfiltered experience of unity. Meditative traditions mirror this. Advanced practitioners of Zen or Tibetan Buddhism describe sunyata, the void beyond self where subject and object collapse. Neurologically, their brain scans show similar suppression of the default mode network, alongside surges in gamma waves, the fastest brain frequencies associated with heightened awareness and binding disparate perceptions into a cohesive whole. The Tibetan Book of the Dead speaks of clear light, an infinite, luminous consciousness underlying all phenomena. Modern meditators, devoid of cultural priming, report identical encounters, a radiant emptiness that feels paradoxically alive, intelligent, and deeply familiar. What's striking is how these experiences align with panpsychist theories. If consciousness is fundamental, ego dissolution might not be fabricating an illusion of oneness. It could be peeling back layers of biological conditioning to reveal a deeper truth. The brain, in this view, isn't generating consciousness but filtering it, narrowing cosmic awareness into a manageable stream we call me. Psychedelics and meditation might temporarily disable that filter, letting the floodgates open. Critics argue these are just brain glitches, neural misfirings under chemical influence. Yet the consistency across unrelated individuals, from Amazonian shamans to Silicon Valley techies, suggests something more. When a DMT user and a monk who have never met describe the same ineffable presence, the same loss of boundaries between self and stars, it's hard to dismiss as mere coincidence. Either these tools are unlocking a hidden layer of reality, or they're revealing the brain's astonishing capacity to simulate the sublime. Either way, the implications are profound. If the universe can be felt as conscious, that experience, however subjective, becomes part of the data we can't ignore. Quantum sensors could become the stethoscopes of cosmic consciousness, picking up vibrations in space-time that our current tools miss. These devices, harnessing the bizarre properties of entanglement and superposition, might detect subtle fluctuations in gravitational waves or dark matter densities fluctuations that follow patterns too complex to be random noise. Imagine arrays of these sensors orbiting black holes, not just studying their gravity but listening for rhythmic signatures buried in the chaos, like deciphering a heartbeat in static. What if black holes don't just collide but communicate, their mergers encoding information in ways we're only beginning to suspect? Galaxy-scale interferometers take this search even further. Today's instruments like LIGO span kilometers to catch gravitational waves, but future versions could leverage entire neutron stars as natural antennae. Pulsars, with their lighthouse-like beams, already serve as cosmic clocks. Network them together across the Milky Way, and you've built a telescope sensitive enough to catch spacetime's faintest murmurs, perhaps even traces of large-scale processing in the cosmic web. If galaxy clusters are nodes in a vast neural network, their gravitational interactions might leave imprints akin to brainwaves pulsing across millions of light years. Then there's AI, the wild card in this cosmic detective story. Training machine learning algorithms on petabytes of cosmic microwave background data, we might uncover anomalies that human analysts overlook. Subtle asymmetries in the afterglow of the Big Bang could hint at intentional structure, like fingerprints left in the fabric of reality. Some theorists even propose that the universe's constants, the speed of light, the strength of gravity, aren't arbitrary but optimized, as if fine-tuned by a higher-order intelligence. AI could run simulations testing whether these values cluster around computational efficiency, suggesting a universe built not just to exist but to think. The boldest vision, a hybrid approach combining all three. Quantum sensors flag anomalies, interferometers map their structure, and AI deciphers their meaning. Together, they might reveal a cosmos humming with something far stranger than mere physics, a symphony of self-aware spacetime, where every particle plays a note in a melody we're finally learning to hear. The tools don't just expand our reach, they redefine what we're searching for. Not aliens, not gods, but the universe itself, awake, aware, and waiting to be understood. Of course, the idea that the universe itself could be conscious invites skepticism, and rightly so. One major critique is that we're falling into the trap of anthropomorphism, projecting human qualities like thought and awareness onto something vast, impersonal, and fundamentally alien. After all, the universe doesn't have neurons or a central nervous system. It doesn't exhibit behaviors we recognize as intentional. To claim it's thinking might just be a poetic metaphor stretched beyond scientific validity. Critics argue this is akin to ancient cultures attributing thunderstorms to angry gods, a way of making the unknown feel familiar, even if it's not accurate. Then there's Occam's razor, the principle that the simplest explanation is usually the correct one. If we observe complex structures like galaxy clusters or quantum entanglement, do we really need to invoke cosmic consciousness to explain them? Physics already has robust frameworks, general relativity, quantum field theory, that describe these phenomena without resorting to mind-like properties. Adding consciousness to the equation might seem like unnecessary complexity, a solution in search of a problem. Why assume the universe is aware when dumb, mechanistic laws suffice? And let's not forget the hard problem of consciousness articulated by philosopher David Chalmers. Even in human brains, we still can't explain how subjective experience arises from mere matter. If we can't solve it for our own 3-pound organ, how can we credibly scale it up to the entire cosmos? The leap from "we don't understand human consciousness" to "the universe is conscious" feels speculative at best, reckless at worst. Without a clear mechanism linking physical processes to awareness, the idea risks floating in the realm of metaphysics rather than empirical science. Yet counterarguments persist. While anthropomorphism is a valid concern, panpsychists and others argue they're not claiming the universe thinks like a human, only that some form of proto-awareness could be inherent in matter itself, a property as fundamental as mass or charge. This isn't about projecting human traits, but recognizing a spectrum of consciousness from atoms to galaxies. As for Occam's razor, proponents suggest it might not favor materialism as neatly as assumed. If consciousness truly is fundamental, then a universe that generates it effortlessly could be simpler than one where it mysteriously emerges from inert particles. The hard problem, ironically, might even support cosmic consciousness. If subjective experience can't be reduced to physical processes, perhaps it's because it's already woven into those processes. Instead of asking how brains produce awareness, we might ask how awareness manifests through brains and by extension through cosmic structures. It's a radical inversion, but not an illogical one. Skepticism keeps these ideas grounded, and that's healthy. But history shows that many breakthroughs from heliocentrism to quantum mechanics began as heresies. The line between visionary and delusional is often drawn in hindsight. Whether cosmic consciousness falls into one category or the other remains to be seen. But the debate itself stretches our imagination, forcing us to confront how little we truly understand about the nature of reality and our place within it. The next frontier in cosmic consciousness research isn't just about theorizing, it's about designing experiments bold enough to test whether the universe itself is aware. Upgrades at CERN, the world's most powerful particle collider, could soon push this inquiry into uncharted territory. With its high luminosity upgrade set to go live in 2029, the Large Hadron Collider will smash protons together at unprecedented energies, probing deeper into quantum entanglement and the nature of spacetime. One tantalizing possibility: hunting for anomalies in particle behavior that hint at a universe where observation isn't just passive but participatory. If entangled particles exhibit correlations that defy classical physics even more dramatically than we've seen, it might suggest that information exchange isn't confined to local interactions but woven into the fabric of reality itself. Meanwhile, quantum gravity probes like NASA's upcoming Laser Interferometer Space Antenna will listen for ripples in spacetime with sensitivities far beyond current detectors. These gravitational wave observatories could uncover patterns in black hole mergers or neutron star collisions that resemble, however faintly, information processing. Imagine detecting a sequence of gravitational wave chirps that repeat in mathematically significant intervals like cosmic Morse code. While mainstream physics would first attribute this to natural resonances, fringe theorists are already asking, what if these aren't just echoes of collisions, but fragments of a deeper, universe-scale computation? Interdisciplinary collaborations are fueling this revolution. Neuroscientists and astrophysicists are now pooling data, comparing the network structures of galactic filaments to neural connectomes in mammalian brains. Projects like the Human Brain Project and the Virtual Brain are adapting their algorithms to simulate cosmic-scale networks, testing whether the same principles that govern thought in our skulls might operate in the voids between stars. Even philosophers are joining the fray, refining panpsychist frameworks to accommodate potential empirical findings like a universe where consciousness isn't emergent but intrinsic, with matter and mind as two sides of the same coin. The boldest experiments lie ahead. Quantum biology labs are probing whether photosynthesis's eerie efficiency and bird navigation's reliance on entanglement are mere quirks, or evidence of a living universe exploiting its own quantum substrate. Meanwhile, dark matter detectors like LUX Zeppelin are being repurposed to hunt for more than just invisible particles. If dark matter's gravitational whispers show unexpected coherence, could they be the universe's way of thinking in a register we're only beginning to hear? Critics argue these efforts stretch science beyond its limits, conflating metaphor with mechanism. Yet history shows that today's heresies often become tomorrow's textbooks. Whether these experiments confirm cosmic consciousness or debunk it, they're guaranteed to reveal something profound about the universe and about our place within it. The tools are arriving, the questions are crystallizing, and the answers, whatever they may be, will rewrite our understanding of reality itself. So where does this journey leave us? We've traced the threads of cosmic consciousness from the whispers of ancient philosophies to the cutting edge of quantum physics. From the eerie parallels between neural networks and galactic filaments to the tantalizing possibility that black holes and dark matter might be processing information on scales we can't yet comprehend. The evidence isn't conclusive, it's a mosaic of hints, a collage of maybes that challenges us to rethink not just what the universe is, but what it might be. If consciousness is indeed fundamental, woven into the fabric of reality itself, then every star, every atom, every fleeting thought in our minds could be part of a vast, interconnected tapestry of awareness. The universe wouldn't just contain life, it would be life in the most expansive sense imaginable. Our human experience, with all its joys and sorrows, might be a single ripple in an ocean of cosmic thought, a momentary flicker in an eternal dance of self-reflection. But here's the most humbling twist of all. If the universe thinks, we might be more than just passive bystanders. We could be its way of waking up, Every time a scientist peers through a telescope, every time a child wonders at the night sky, the cosmos isn't just being observed, it's observing itself through us. Our curiosity, our creativity, even our conflicts could be part of a grander unfolding, like neurons firing in a mind too vast to grasp its own totality. This isn't about replacing science with mysticism. It's about expanding the boundaries of what science might one day explain. Whether you find these ideas exhilarating or unsettling, they invite us to stand at the edge of the known and gaze into the unknown with fresh eyes. The universe has always been stranger than we imagined. Why should consciousness be any different? So as we wrap up this exploration, let's leave the question hanging in the air like a star waiting to be born. If the universe thinks we might be its fleeting thoughts or its awakening eyes, what do you see when you look into the void? Whatever your answer, stay curious. The cosmos is far from finished surprising us, and if you're hungry for more mind-expanding journeys, don't forget to subscribe. The next revelation might be just one click away.